Hi, how are you?
I'm fine. How are you?
Good.
Okay, I'm still trying to figure out. I think I got it connected correct. Can you see me?
I can see you. Great. Can you tell me a little bit, we've chatted a little bit on Facebook, but can you tell me a little bit more about yourself and what led you to want to take the GMAT?
I'm sorry?
Can you tell me a little bit more about your background and why you want to take the GMAT? You mentioned you're at the trademark office?
Yes, I'm the office manager at the trademark office. I work with patent examiners and also patent trial and appeal board judges. I provide them pretty much support and run the office administrative-wise. And so that's my current background professionally. But I'm finishing up my bachelor's now in the last semester, so I should be graduating in May.
Okay.
With my bachelor's in general business. And so I'm wanting to apply to an MBA program.
Great.
And most require either the GRE or the GMAT. And I've been doing research, so I figured the GMAT would be a better choice because some of the schools that I'm wanting to apply to only accept the GMAT.
Okay, and what schools, schools are those?
Well, they're all online due to my current schedule. So, in my major, I'm wanting to do an MBA with a concentration in nonprofit management. And so that kind of narrows down my options in regards to the schools that are available that has my specific concentration. So one of the ones is Oklahoma State, okay, as well as University of Wisconsin Consortium, University of South Florida, Liberty University, Regent University, Tiffin University, and there's a couple more, I believe. I have an entire spreadsheet that I've been putting together for the schools that I'm going to apply to with my concentration. So
okay, and then do you know what the average GMAT score for most of these schools is?
It depends on the school. Most range from 540 to 670.
Okay, so that's a pretty big gap. About 500 is going to be like smack dab average. 540 is going to be pretty good, and above 600 is going to be very good, elite.
Oh, okay.
Okay.
Wow.
So
yeah. Wow.
If you put in the time, 540 is totally doable. It's just how much time do you have?
My test is scheduled for April the 19th. And so my plan was to take it the first go run, and if my score is not where I want it to be, I have hopefully enough time to take it again before the absolute maximum deadline for the school, one of the schools that I'm applying to. The priority deadline is April 1st. And the final deadline is July 15th or July 1st. So I would prefer not to have to take it again. I prefer to do decent on the first run, but if need be, I'm prepared to take it again.
And then what school is that?
Oklahoma State.
Is that your top choice?
Yes, as of right now. And then there's another one. I forgot the name of that one, but it also has priority application deadline of April the 1st. So since my test is scheduled for April the 19th, I figured I would, be able to get my scores in time to have some type of priority in regards to them reviewing my application.
And then why is this school your top choice? It's just the most flexible for you?
Well, it's close. That's really the only reason. Well, one of the reasons it's a top choice is because it's one of the more affordable ones on my list, credit-wise, price per credit. And it's close to Texas. I would prefer to have found a Texas school that offers the program online with my concentration, but there is none from my research. So being that it's Oklahoma, it's not too far away.
Right.
I kind of like that concept. And after that, also the University of Wisconsin. It's very far away, but it offers my concentration online. So, and then University of South Florida, and then it just goes from there. But yeah, that's mainly the reason why it's my top choice, is because it's closer to my state, and it's pretty reasonable price-wise.
Okay, and then do you plan on switching careers, or are you planning to get this MBA to get a raise at your current job?
Well, it won't, because I'm a contractor for the USPTO. The USPTO, the patent examiners and the management and patent trial and appeal board judges, they're all federal workers,
right.
You know, GS level. But everyone else, security, IT, any other work group, they like to hire and contract small businesses. So they contract to vendors, you know, major vendors before they get to a certain level wise, annual profit wise, they like to contract. So I'm a contractor for them. So the way it's set up is, unfortunately, the agency that I work for and the contract agreement that we're under with the government is there really is no opportunity for growth or promotion.
Okay, I totally understand. I've had jobs like this before too.
Yeah, so I'm pretty much kind of stuck. Even if I was to obtain a doctorate degree, I'm pretty much stuck at this current level, professional-wise, as long as I'm there. So, but with that being said, yeah, I'm not trying to get my degree to move up within that, being that I'm a contractor. Now, if I was to make federal, you know, federal is different. You can move up so many levels, GS-wise. But as of right now, currently, I'm not able to move up. But my hopes and goal would be to use my degree for a totally different, my own professional purposes in regards to working for a nonprofit, starting my own nonprofit. That's my end game.
Okay, great. The reason I asked is I'm happy to help you, hopefully help you get to your GMAT score goals. A lot of times I actually counsel my students to be really wary about getting the MBA degree because, you know, depending how old you are and the time commitment, it can be kind of a dicey proposition on whether, you know, it'll actually pay back. So it's good to have options and to get into these programs and weigh the options. But think really seriously about how much debt and how much time you're willing to be in debt. Because the return on investment is not 100% clear to me. I like teaching the GMAT and sending people to MBA programs, and I found that was a better deal for me than actually getting my own MBA. So it's you know, one of those things where a lot of my students were like, why didn't you yourself get an MBA? And one reason is cost. And it opens up very specific doors. And according to your goals, it sounds like there are a lot of different ways for you to get to those goals, you know, without having to go into a lot of debt. So that's something we can talk about in the future. But I looked at your quiz, and just a few things with the prime numbers. Okay, so 26 is definitely going to be wrong. Do you know why?
No.
Okay, so there's only one prime number that's even. And, okay, so 26 can't be prime because it's an even number. And what we'll do is we'll define what a prime number is.
Okay, let me pull it up. So you're saying prime numbers can't be even?
There's one even prime number.
Is it 2?
Exactly. And 2 is not on your list.
Oh. Okay. So prime number is any number that only has 2 factors.
Exactly. One and itself.
Okay, and I put 26. Is that the only one I got wrong?
No, there's probably a few others. 69 is wrong. Okay, so here's a trick that you may not have come across or you've forgotten. And it seems like really wild when you first see it. If you add 6 plus 9, and let me bring up this board. it adds up to 15.
Mm-hmm.
And 15 is divisible by 3.
Mm-hmm.
And so that makes the entire number 69 divisible by 3. And let me send you this link.
Okay.
Okay, I'm sending you a link to a whiteboard, and we can do some math problems together there.
Okay, you sent it to Gmail or to Facebook?
Gmail.
Okay.
So.
To whiteboard.
And there's a bit of a lag, but this is what I'm trying to show you. So for 69, you can actually add up the digits. And this is a number property that the GMAT will quiz you on.
Oh.
And you can do this with smaller numbers too, like 12. And so 12, I think we could agree, is a multiple of 3, but you could try this by just adding 1 plus 2 equals 3.
So,
yep.
So what? So you're saying, okay, being that 6 plus 9 equals 15, that means, okay, are we on the prime number question still?
Exactly. And so this is very important. So the reason the numbers properties section is so difficult for students is because the GMAT is trying to get you to think pretty abstractly here, and in a way that's going to be different from the math classes that you probably had in high school and college. Usually my strategy with helping my students is that we spend a lot of time on number properties and data sufficiency first, because that's typically the hardest part for my new students.
Mm-hmm.
And you need to start thinking pretty deeply about the nature of numbers. And that means you need to think, when they give you a question, is the number even, odd, negative, positive, 0, or prime?
Okay.
And you'll notice a lot of these problems on here are just X's and Y's, and they give you a few attributes for the numbers, but it seems really abstract. And so early on with a lot of the early quant lessons with me, what ends up happening is we're not even dealing with real numbers until later on. And once we do, my students are usually pretty happy. And it's pretty strange to think this way, but it'll become second nature. And so it's very important that we get the prime numbers down first. And a prime number is a number with 2 factors, itself and 1.
Okay.
And the GMAT will quiz you on this and ask you this in a lot of hidden, tricky ways. And so the first number that would be incorrect would be 1. 1 only has 1 factor.
Itself.
Exactly.
Okay.
Okay, and I'll get 26 out of the way. And then right now, when I'm scanning the numbers, I'm actually looking for numbers where I can add 2 numbers up, and they equal a multiple of 3. And the one that sticks out right now is 39 and 51 and 57.
So if they equal a multiple of 3, that means that they're not prime numbers?
Exactly.
If you add them up? Okay.
And let's
so
do
what
these.
About 26, 2 plus 6 is 8. That's not a multiple of 3, so that's a prime?
So the issue with 26 is that it's an even number.
Oh, okay. So it has to meet both parameters. It must, okay.
Exactly.
Okay.
Okay, and then I'm looking at 39 and 51 and 57.
Mm-hmm.
And let's do these together. 39, 51, and 57.
Okay.
Why did those stick out to me?
Okay, because 9 plus 3 is 12, and that's divisible by 3.
Exactly.
5 plus 1 is 6, and 7 plus 5 is 12.
Right. And there are going to be certain numbers that you can use as like roadmaps. And so you know that 60 is definitely divisible by 3. Because that'd be 3 times 20, right?
Yes.
And look how close 57 is to 60. So 57 is only 3 away from 60.
67 is only 3 away from 60.
57, right.
57. Okay, yes, there is a lag too in the audio.
Oh, okay, sorry about that.
In and out. No, that's okay.
Okay, so 39, 51, and 57, that's me just doing kind of a spot check. And 39 would be 13 times 3. And 51 is probably the most common one that my students mistakenly put down. And this one's harder to see. You can probably see that 5 plus 1 equals 6, but you need to remember that 17 times 3 equals 51. And that 19 times 3 equals 57.
Mm-hmm.
Okay?
Mm-hmm.
And so there's going to be a lot of breaking numbers down to their factors, into their prime factors. And let's do this one together. 69. What are the factors of 69? So we know that 1. Say that again?
Is 23 a factor of 69?
That's right. 23 and what else?
3.
Exactly. Very good, very good.
Okay, so okay, so being that that has more than 2 factors, of course, more than 1 in itself. All of these are prime numbers. See, yeah, it's just, I don't know. It's so much information. I've been going through the OG and, of course, doing the Magoosh study plan and doing their videos, and it's just so much information in such a short amount of time with number theory.
Right.
And just trying to remember it, you know. So, yeah, okay.
It's okay, it's okay. So, how much time do you have to devote to this every week? Can you put in 6 hours? Can you put in 10 hours?
Wow, right now I'm trying my best to do at least an hour a day.
Good.
And that's because my commute is bad. I have a long commute, but hopefully that'll change soon. Then I work full time. Then we have 4 children.
You've got 4 kids? Wow.
And I'm still in school.
Right.
I'm taking 6 credit hours now. So, and at work, I'm able to do more than an hour, depending on how busy I am at work. But I've been lately averaging about an hour a day.
Okay. Okay, great. Yeah, that's all I asked for. You know, if you, you know, most of my students are going to be working adults. Some of them have kids. You know, if you've got a family of 4, you know, you're going to have, I have like 1 kid. I know like that's enough work. So times 4 would be a crazy amount. Just don't try to rush it. You know, you're right. It is a lot of material, but slow and steady wins the race.
Yeah.
I don't recommend trying to cram as much as possible the month before the exam. And the biggest reason is that, you know, that strategy works for some students, but you don't know when you'll burn out. And my concern about students who try to study, they do the bulk of their studying right before the exam, is that they don't know exactly when they're going to burn out. And if you burn out right before the exam, that's going to be the worst time to burn out. You want to burn out far enough ahead of the exam as to where you can recover. And you're right that there's a lot of information and it's super dry and it's not fun. But you gotta plan for that. Okay, so I think I had sent you a study plan before, and the bulk of the study plan really is practice test. And you and I will work on these exercises together, but you'll notice eventually if you do a lot of these questions, you'll be able to figure them out, but it's totally different game when you're under time pressure. And do you know very much about the computer adaptive algorithm?
Yeah, a little bit. I've watched a couple of videos on it. Pretty much it adapts to your level of proficiency. You know, if you get a certain question right, they'll present you with harder questions. Right.
Okay, so your name's Nikiwa, right?
Yes.
Okay, yes. Nikiwa, it's very important that you manage your psychology here, because one of the difficult things about doing a test like this is when you start seeing easier questions. You have to manage your psychology, because if you start seeing easier questions, you might think that you're bombing the test. And so when you start seeing easier questions, you have to manage your own psychology and power through it. Even if you make mistakes early on, you can still recover from them. And it's many of the questions are going to be experimental. So if you see an easier question, it may not be because you're getting a lot wrong. It may be just, the GMAT is giving you an experimental question that they're trying to get data on.
Oh, okay.
Right?
Okay.
One of the test prep companies I work for estimates that a quarter of the GMAT questions are experimental, which is a lot. And the reason I mentioned the computer adaptive exam is that it's of the big tests, it's probably the most advanced, but like the hardest to get used to. Okay? There are a few other subjects that we need to cover, but let me choose 93 as well. So from what you've learned about these prime numbers, what's wrong with 93?
Okay, well, 9 plus 3 is 12, number one, and that's divisible by 3, so that makes it not a prime number.
Okay, good. And what are the factors?
Okay, the factors is 31 and 3.
Excellent. Okay, and then I'll go through a deeper dive later on, and I'll send you which of these numbers are missing. But let's look at the squares. I'll do like a quick spot check. How is this? When you were doing the squares, did you have to look a lot of these up? Did you remember them?
I had to actually manually, physically calculate them with paper.
Okay.
Some of them I knew, 2 squared, 5 squared, all the way up into maybe 13 squared. I had to start calculating, with paper and pen. Okay,
that's great. On the GMAT, they'll give you that small little whiteboard to write on. And you can't use a calculator. So if you have to do 2 by 2 long division on the test, this is actually why I make my students do it. But it looks like 17 onward, there are a few mistakes. Okay, so 20 squared is going to be 400, not 300.
Yeah, yes, I see that now. That was, it might have been a typo.
Right, and so here, just as a spot check and a sanity check, the reason I know that's wrong is because I want to see the numbers going up.
Yes.
And that one, it drops down, and so that's clearly going to be wrong.
Okay.
Okay, and I think 17 squared and 18 squared are going to be wrong.
Oh, okay.
So let's do 17 squared again.
Okay.
What's 7 times 7?
49.
Okay, and if you did 17 times 17, I would expect the units digit to have a 9 in it.
You're right. I don't. Yeah.
Yeah. So these are the kinds of things that we can work on in practice, and you can learn from while you're doing practice. So let's do this together right now. Let's do 17 times 17. And,
okay.
And I'm opening the whiteboard right now. Okay, and can you see the whiteboard?
Yes.
Okay, and then how would you do this? How would you start off?
I would write 17 on top of 17 with the
Great.
multiplication sign and start in the ones column. 7 times 7 is 9. I'm sorry, 49, write the 9, carry the 4.
Okay.
7 times 1 is 7, plus 4 is 11.
Great.
So then I'll write the 11 down next to the 9, and then under the 11, starting under the 1, I will multiply 7 times 1 is 7. So I'll put the 7 under the 1, and then 1 times 1 is 1, and put that under the second 1, and then add down. So bring the 9 down, which would be 9. 7 plus 1 is 8. 2 plus 2 is 2.
Okay, great. So you did it correctly there, but something happened during practice. So I think you put 285.
Yeah, it should be 289.
Right, so you're close there. But I think that was probably just a mental math error. Okay, and then the same thing with 18 times 18. So, same thing. What's 8 squared?
8 squared is 64.
Right, so I would expect to see 4 in the units digit.
Yeah.
So let's.
That's right.
Okay, great. And so that makes sense to you. And let's do 18 times 18.
Okay. 18 times 18. 8 times 8 is 64, so I would write the 4 under the 8, carry the 6. 8 times 1 is 8. 8 plus 6 is 14. I'll bring down the 14, which is 144. Then 8 times 1 is 8. Bring the 8 under the 4, the first 4. 1 times 1 is 1. Bring that down. Then add. It should be 324.
Great. Okay, so it looks like you were off by 4 for both of these, so at least you're consistent. Okay, and with these numbers, there's 2 ways to memorize them. You could just straight up memorize this timetable, but it does help to do some of these. So this would be wrong as well. 19 squared.
Yeah.
And 20 squared. So 17 to 20 squared you seem to have problems with. So try to do 19 squared on your own right now.
Okay. 19 squared. 361.
That's it?
I'm sorry. Is that right? Oh.
Yeah, that's right. Yeah, don't be sorry.
So do I need to try to memorize this, or is it something that?
And it's okay to memorize it. the concern is you might memorize things a little bit incorrectly. Better to do both, like a little bit of both, where you memorize it and you also do them by hand, because you're going to have to do 2x2 calculation a lot on the test.
Okay.
Okay, and then let me just check the last few. Okay, and it looks like you're off again. 23 squared. So
which one?
23.
23. Oh, okay.
Yeah, what's wrong there?
It should be 529.
Good.
Yeah, I'm off by 4 again. I don't understand that. All of them were off by 4.
Yeah.
That's weird.
And no idea? No idea why?
No idea why whatsoever.
Okay, well, it looks like you're able to fix it on your own now. Okay, so this problem here, this is when things start getting really abstract. Is the integer y even?
Okay, we're on the next one. Is it? Yeah. So I selected C.
Right. Okay,
for this.
And tell me your reasoning.
I'm sorry?
Tell me your reasoning.
Okay, well, I figured that I figured that number one it doesn't provide enough information because, x squared, it could be it could be an even or odd. I'm sorry. It's just by looking at it, I figured it's not enough information for it to be even.
Okay, so you had a hunch, but this is where you have to articulate it, right?
Yeah, I really didn't.
So they're asking you about y, but you're telling me about x, and you're telling me x could be even or odd.
Yes, pretty much, and that's why I see x. X could be even or odd, positive or negative.
Right.
On number 2, I figure x is 9 because 9 times 9 is 81.
What about?
So I figured that if we know.
What about negative 9?
Yes, or negative 9. That's right. And so let's say x is negative 9 or 9. If in one x is 9, okay, and it still comes out to 81, that means that negative 3 to whatever power would have to equal 81. Right? Am I thinking about this right?
Okay, so with number 2, the concern here is for statement 2, you need to be aware that x can be 9 or negative 9. And the GMAT will nail you for this. If you get a question where they ask you, can you solve, and you're able to solve negative 9 and 9, that's not enough. You have to actually narrow it down to either negative 9 or 9.
Oh.
And so when I said earlier, they want you to think pretty deeply about the nature of numbers here. You've got to think about all the numbers left of 0.
Okay.
Okay.
And those are integers, right? Positive and negative.
That's okay. Right. What's an integer?
It's all the numbers on the number line, whole numbers, except for 0. Is 0 not considered an integer? Would it be all the numbers to the left and all the numbers to the right?
Yeah, but so it wouldn't be fraction. So it wouldn't be fractions, and it wouldn't be square
roots.
roots.
Or decimals, right? Okay, would decimals fall into that?
A decimal like 9.0 would be an integer.
Okay.
So the answer is usually a decimal would not be, but there's a special case where the decimal is 0.0.
Okay.
Yeah, so 9.12. Sorry, say that again?
So 0 is not an integer.
0 is an integer.
Oh, so 0 is an integer.
Right.
Okay. Okay. Yeah, I noticed on the practice test, they're always asking, the word integer comes up a lot.
Right.
On some of the questions that I have done. And prime factor, prime number, like the question number 1 that you have on the demo lesson. So I do see that a lot, on the some of the practice questions that I've done. But with this question here, did I get it right?
No. No, but
No.
you did it incorrectly the same way all my students do it incorrectly. And so let me tell you this. The most common temptation on data sufficiency is to jump to C. And you have to be very, very disciplined, and you have to treat both statements separately. And so for statement number 2, the first mistake was not accounting for -9.
Mm-hmm. Yeah.
And notice they're asking you about the integer y. They don't ask you about whether x is an integer. They don't tell you that x is an integer.
That's true.
Right?
That's true.
So you're actually making an assumption. And that's bad. So x doesn't have to be an integer. X could be square root of 9.
Wow.
Do you see that? Yeah, so if we made x square root of 9 and then we squared that number, what would you get?
Well, if x is the square root of 9, what would that be?
Let me draw this on the board.
Yeah.
Okay, so if I make x, if I make x square root of 9 and you square that, remember, squaring is multiplying a number by itself. So square root of 9 times square root of 9.
Okay. I was thinking the square root of 9, which is times 3. And so that's why I was thinking, well, that doesn't equal 81. Okay, so with that would be the square root of 9 times the square root. Yes, okay. The square root of 9, which would that be the square root of 81?
No. Okay, so yes, that's right. But what's the square root of 81?
9.
Good. Okay, so notice here, I'm treating statement 1 separately. I'm not looking at statement 2.
Okay.
So the temptation here is to peek. While you're doing statement 1, while you're trying to figure out whether A is the right answer or not, you might have the temptation to look at statement 2. You really, really have to resist that temptation. So if we make x equals square root of 9 and we square it, yeah, you're right. We get square root of 81, which equals 9.
Yes.
And then on the right side, we have -3 to the y power. How do we get that to equal 9?
It would need to be squared, right?
Okay. And so that means y is?
I'm sorry, not squared. It would have to be to the 4th power? Or am I thinking about this wrong? No, I'm right. I'm right. So it would be -3 squared?
Okay, so y would equal?
3. I'm sorry, 2.
Exactly.
And that's even.
Yeah, exactly.
So I would have to, okay.
So I started you off with a really hard one. This is one that most of my students get wrong.
So I have to look at statement 2 to really figure out statement 1?
No.
No.
Actually, what I'm trying to say here is you should treat statement 1, you should spend more time on statement 1 and think about what statement 1 is telling you before you go on to statement 2. The temptation is to look at statement 1 really quickly and then incorporate the information in statement 2 and then to jump to C.
Mm.
And so C is the most common mistake for this question.
Okay.
And the reason is exactly the way you were thinking about it. You were trying to solve for x in statement 2 and plug that back in statement 1, but there was no indication that x is an integer.
Mm.
It can actually be square root of 9.
Yes.
And,
yes. Wow.
Yeah, and so another trick here too, and I'll write this equation. I'll write statement 1 again. Statement 1 is x squared equals -3 to the y.
Okay, for some reason I can't see what you're writing now.
Click refresh.
Okay, let's see here. Okay, I see it. X squared equals -3y.
Yep. And so look at the top. Notice to the exponents. It's x to the 2 and -3 to the y.
So you have 2 equals y?
Yeah.
Why is that? I guess you can explain.
Yeah, and it's because of that example we used earlier with x equals square root of 9.
Okay, so is this a pretty much a formula that I can use in any scenario? For instance, if I see something that says x to the 4th power equals -5y, could I assume that 4 would equal y?
Well, as long as they don't tell you anything restrictive about x in the rest of the statement. So if the question is set up exactly like this, yes, but you got to be really careful because you notice here the fact that they didn't tell you anything about x was a really big deal.
Okay.
So it's all in context. Okay. I'll probably in the future I'll move this problem down. You've definitely figured it out, but this is one of the harder problems. The next one here.
So which
Yep.
one? I'm sorry. Which one was the answer?
Okay, so for this one, it's going to be A.
A, yes. Okay, so A is sufficient alone.
Right.
Wow.
And the reason is because you're making an assumption about x and you don't need to.
Okay.
And
Okay.
and here, x can be positive or negative. But when you have a negative number squared, it's going to be positive.
Yes, that's true. So, wow.
Okay, wow. Okay, and so one of the fun things about studying for this test is you get insights like this. And they're very abstract insights, but they're still fun to think about. Okay, let's go to the next question. Is x plus y odd?
Yeah, I really wasn't for sure on this one as well. I figured that, neither provided enough information by themselves, but together we might could, figure it out.
Okay, so you picked the right answer, but what we want to work on here are just examples to choose. So let's start thinking of numbers that represent x and y. If statement 1 says x is not an integer, what kind of numbers do you want to substitute for x?
We can do square root or decimal or fraction.
Yeah, let's do decimals and fractions.
Okay.
Okay, so let's do 3 over 2. And that would be 1.5. And for y, we could do 1/2. Which is what is a decimal?
0.5.
Good. And what happens when you add them together?
You get 2.0.
Okay, is that even or odd?
Even.
Okay, good. So that's one scenario where we can make this even. Can you think of a scenario where we plug in different numbers and we get an odd number? And I'll give you a clue here. Is there any restriction on making x equal y?
No.
So let's make both of them 3 over 2.
Okay.
And then what happens when you add them together?
Oh, if we add 3 over 2 plus 3 over 2?
Yep.
That's 3 or 3.0.
And that's even or odd?
It's odd.
Great. So notice there, you thought through the process and you created a scenario where you got an even number and an odd number. And that's why E is the right answer.
Okay, okay.
Okay? So this is the kind of process they want you to think through. Can you create, a factual statement and a counterfactual statement?
What statement?
Like a factual statement and a counterfactual. Like one scenario and another scenario.
Okay, you're asking me to create one?
You just did.
Okay.
When you added those two numbers and you got an even number, and then you added them again, you got an odd number. And so there, because you were able to get an even and an odd number, you can't answer the question sufficiently. There's just not enough information.
Wow, okay. So I need to really think and analyze these data sufficiency questions in that manner.
Yeah.
Pretty much.
Yeah. And this is why I start my students off with this stuff, because once you start doing the problem solving with real numbers, it'll seem a lot easier.
Really, I've kind of thought the data sufficiency questions has been a little easier since I've been, studying.
Right.
And the problem solving seems like they're a lot harder for me, which is weird, I guess. I don't know.
Okay, well, let's do some more of these. Okay, so for the next one, x to the y power equals 16 for statement 1, and statement 2 says y equals 4. So you need to solve for x. And the advice earlier was don't try to combine these statements right away. Treat them separately.
Mm-hmm.
And you chose statement A here. Tell me why.
Really, because I was thinking 4 to the 4th power. I'm sorry, 4 squared is equal to 16. I wasn't considering that it could be -4, or it could be something that's not even an integer. I wasn't even considering that. I just immediately looked at it and saw, okay, it could be 4 squared equals 16. So yeah, we can solve for that. I don't know what I was thinking when I was trying to figure that one out.
Okay, so here's the problem. With statement 1, I think you were able to spot one set of factors, 4 squared. But 16 is going to have more factors than just that. So
16 and 1.
Exactly, 16 and 1. But what about 2?
Yes, you're right. So wow. So what would that be? Would it be 2 to which power?
You tell me. What's 2 squared? Okay, what's 2 squared?
2 squared is 4. So would it be 2 to the 3rd power?
What's 2 to the 3rd power? Okay, so let's do this by hand on the board. As a quick refresher. So 2 squared is going to be 4, and 2 cubed is just going to be the previous answer times 2.
So it would be 8.
Good. And then 2 to the 4th is going to be that previous answer times 2.
16.
Great.
Okay.
I'm not done yet, though. There's another wrinkle that we talked about earlier, but I think you might be forgetting.
Okay.
What about the negative numbers?
Yeah. So it could be -2 as well.
Exactly.
Mm.
So if you have to solve for, so if the answer can be -2 or 2, it's not sufficient.
Mm. Okay, so x to the y power pretty much is not sufficient by itself, statement 1.
Right. And you've just got too many factors here. It could be 16 to the 1, it could be 4 squared, it could be 2 to the 4th power, and it could be all of those x numbers as negative. So you got a lot of options. And then statement 2 tells you that y equals 4.
Well, I knew that wasn't enough to solve for x because there's not even x in that equation.
Good.
Right.
Right.
But I figured if we use them, without looking at it, if we use them together, could we solve for x?
And let's try that right now. Okay, so if we say that y equals 4, what's x?
2.
And?
-2.
Exactly. So what's the answer?
Oh. So it's still not enough to solve for x.
Exactly.
Pretty much.
Exactly. And so this is where the GMAT will nail you. A lot of students will be able to get to -2 and 2, and they'll choose C, but that's not correct. It's going to
be E?
Exactly.
Wow.
Okay, it sounds like you're getting the hang of this.
Yes, I understand a lot better now. I will say that much.
Okay, great, great. Okay, this next question is really important because this is a kind of question where they're trying to really understand if you understand this little chart right here, and I'll draw it. And I'll represent even numbers by E. And so an even number times an even number equals what?
An even number times an even number equals an even number, right?
Yep.
Is that right?
That's correct. And then what about an even times an odd?
Would that be an even number as well, or is it an odd?
You're right, but you don't sound very confident or sure of yourself. So how do I prove it to you? How do I prove it to you?
Okay.
Okay, so let's use, so for these kinds of numbers, when you plug in numbers, use the easiest numbers possible. You know, don't be a hero. So for even numbers, put in 2, and for odd numbers, put in 1.
Okay.
So what's 1 times 2?
2.
And is that even or odd?
Even.
Good. That's all you need to know.
Oh, so I don't have to keep going to other numbers to try to see if it's the same.
Right.
With 4 times 3 or something. Okay.
And what's 4 times 3?
12.
And so if you multiply an even times an odd there, what do you get?
Even.
Good. Okay, and so for these kinds of questions, you don't even have to multiply the numbers out. Like, you don't actually have to solve for 12, but you have to know it's an even number.
Okay.
Okay, and then the last one is an odd times an odd number is?
Oh, would it be odd?
Yep. But let's use real numbers. What's 1 times 1?
1.
Good. So this is the kind of reasoning that they're testing you on this next question. And so basically, this chart that I have up here, E times E equals E, E times O equals E, O times O equals O. That's what you need to think of when you're answering these 5. So there's actually more than one of these has to be even. And so the setup says m is an integer and n is an even number. Which one of these has to be even? And the thing I told you earlier about using really simple numbers, they tell you that n's an even number. So let's use the simplest even number we can.
2.
Okay. So for statement 1, n equals 2, and then what's n plus 1?
3.
Okay, good. And so 2 times 3 is?
6.
And is that even or odd?
Even.
Good. But notice statement 1 follows this second setup. E times O equals E. And so this one's going to have to be even.
Statement 1, right?
That's right. Statement 2?
Okay. That would be even as well, right?
Right. Why?
Because even times even, and being that it's squared, it's multiplied by itself.
Yeah. So even times even is going to be even.
So both of those are evens. So how would we select being, aren't they looking for just one answer choice?
Where does it say that?
Oh, I guess I assume.
Right. You got to be really careful about that.
Wow.
Okay, so we're not done yet.
Okay.
So for statement 3, n plus 1 and n plus 3, are those numbers even or odd?
Okay, we use 2 as an example. 2 plus 1 is 3. 2 plus 3 is 5. 3 times 5 is 15. It would be odd, maybe? Because we're multiplying an odd by an odd?
Yeah, you're totally right, but you don't sound confident.
Because I kind of went through that in my brain pretty fast.
Okay, let's...
I wanted to make sure I was thinking and analyzing it correctly.
Okay, so we're studying and we're doing practice. This is the time to understand the material deeply. The practice test and the real test is when you need to be concerned about speed. But right now, it's understanding.
Okay.
So let's, you plugged in n equals 2, and you were able to figure out that another way to represent this would be 3 times 5.
Mm-hmm.
And so that would be an odd number times an odd number equals an odd number.
Yes.
And that's it. That's right.
Okay, so that wouldn't be even. So number 1 and number 2 must be even.
That's correct. And then we have 4 and 5 left.
Okay, 4. On that one, how would we know if it must be even or not?
Let's do what
there's
being as there's what? So in the other problems, you were plugging in 2 for n, and you don't know what m is, but let's create a scenario where n is even and m is odd.
I'm sorry. And m is odd, it would be even.
Okay. Good.
So, okay, I get it. It doesn't matter if m is odd or even. Being that n is even, the answer would still be even.
Exactly. And so on the whiteboard, basically what they're doing is translating that into these first 2 statements.
Mm-hmm.
And so the first one would be, if you make m even, it would be even times even. And then the second one, if you make m odd, it would be even times odd. And so the main insight here, so 4 must be even. Okay, and let's do Roman numeral 5. And you underlined this one earlier, and I want you to retrace your steps. What were you thinking before? What numbers were you using?
I didn't. On this one, I was lost.
Okay, that's fine. But now you know more than you knew last night. So knowing what you know now, how would you approach Roman numeral 5?
I would even number.
Sorry, you're breaking up a bit.
Even. Okay, small even number for n, make it 2. Then I would assume that m is odd.
And what odd number?
Yes.
Okay, so what would that equal?
An even. It will be an even number.
Okay.
Am And
Yeah, one sec.